How do magnetars cause fast radio bursts? Imagine a star so dense and magnetic that it can twist the fabric of space around it. That's what a magnetar is, a neutron star with magnetic fields so strong they are trillions of times more powerful than Earth's. These magnetic giants are like cosmic laboratories where extreme physics happens every day. Now, some of the most mysterious signals coming from space are called fast radio bursts, or FRBs. These are incredibly quick flashes of radio waves that last only a few milliseconds but can be as bright as the entire Milky Way galaxy. Scientists have found that some of these bursts actually come from magnetars, which is a big clue about how they are created. The main idea is that FRBs happen because of sudden, energetic events in or near a magnetar's magnetosphere, the magnetic bubble surrounding the star. One way this can happen is through a starquake. Think of it like a crack in a very thick glass. The immense magnetic stress causes the crust of the magnetar to fracture suddenly. When this crust shifts or breaks, it releases a huge burst of energy that disturbs the magnetic field around the star. This disturbance can send out a powerful burst of radio waves that travel across space and reach Earth as an FRB. Another way these bursts can happen is through changes in the magnetar's spin and magnetic field. Sometimes, magnetars experience abrupt spin changes called glitches. These glitches are like sudden jolts that can shake up the star's magnetic field. When the magnetic field reconfigures or snaps, it releases a lot of stored energy. This energy can then produce a burst of radio waves that escape the magnetar's environment. These magnetic fields are twisted and store enormous amounts of energy, so when they suddenly straighten out or break, they send out intense signals. One tricky part is understanding how these radio waves escape the dense plasma around the magnetar. The environment is so extreme that it's hard to imagine how bright signals can get out without being absorbed or scattered. But recent studies show that the radio waves are likely generated very close to the star, within a few thousand kilometers of its surface. This is astonishing because it means the signals are produced right in the magnetosphere, where the magnetic fields are strongest and most chaotic. In essence, magnetars cause fast radio bursts through a combination of sudden crustal shifts, magnetic field reconfigurations, and spin changes. These events disturb the magnetosphere and releases a burst of radio waves in a flash. It's like a cosmic high-energy experiment where magnetic forces twist, snap, and send out quirky signals that puzzle astronomers. Understanding this process helps us learn about the extreme physics happening in the universe and how these mysterious bursts can be used to study the space around us.